All right. Here we're going to walk through some additional examples of binary relations to see what properties they have of the ones that we studied in the previous section, which are reflexive, symmetric, and transitive. So in our first example, we have the binary relation on the set of natural numbers, which is defined by the ordered pair AB is in the relation if and only if A is less than or equal to B. And we want to know, is it reflexive, is it symmetric, is it transitive? All right. So let's start with reflexive. I'm just going to abbreviate that REF. So remember, for reflexive, we suppose that we have an arbitrary element in our set, which in this case is the natural numbers. So let's suppose, I'll just call it A, that we have some natural number A. And we want to know, is the ordered pair A comma A in the relation? Well, what does that mean? As an ordered pair, you get to be in the relation if you satisfy this criteria. So in terms of what we have here, A comma A, that would be equivalent to asking ourselves, is A less than or equal to A? And definitely the answer there is yes. So we would say R is reflexive. All right, moving on to symmetric next. So remember, symmetric means that we take two elements from our set, so two natural numbers A and B, and we assume that the ordered pair AB is in the relation. And we want to know, is the ordered pair BA, also in the relation. All right, so we have to go off of what we know. We know that the ordered pair AB is in the relation. What does that mean? That means that it fits the definition up here, or in other words, A is less than or equal to B. So we know A is less than or equal to B. Does that mean that B is less than or equal to A? Hopefully you're questioning that and thinking probably not. Here's an example. 3 is less than or equal to 4, but 4 is definitely not less than or equal to 3. All right, so that's in math what we call a counterexample. And because we found one example of natural numbers that don't have this property, we say that R is not symmetric. All right, so then moving on to transitive. So here, there's kind of a lot of things going on. We assume that we have three elements of the set, so I'm going to call them A, B, and C, which are all natural numbers, and we know that AB is in the relation, and we know that BC is in the relation. And what we're asking ourselves is, does that mean that the ordered pair A comma C is in the relation? So what we do here, again, we want to start with what we know, and we know these two things, that AB is in the relation and BC is in the relation. Well, what does that mean? That means that A is less than or equal to B, and B is less than or equal to C. All right, and hopefully your understanding of the less than or equal to symbol would indicate to you that we can kind of put these together, since this B is the same as this one. We can write that as one giant inequality, which from that we can conclude that A is less than or equal to C, or in other words, that the ordered pair A comma C is in the relation, thus we say R is transitive. All right, so this particular binary relation has the properties that it is reflexive, it is transitive, and it is not symmetric. All right, let's move on to our next example. So in this example, the binary relation R is on the set of all people in the world, given by A comma B is in the relation. So remember, those are two people, if and only if A and B have the same parents. All right, so this is not so much a mathematical example, but kind of a different way to think about these properties. So again, let's start with reflexive. So for reflexive, we start with an arbitrary element in the set of all people, which this is a funny way to write that, but all right, so lowercase a is a person, right? And we want to know, is A comma A in the relation? Or in other words, do A and A have the same parents? well, you have the same parents as yourself, so definitely yes, R is reflexive. All right, next would be symmetric. So here we would say A and B are people with A comma B in the relation. Well, what does it mean that the ordered pair AB is in the relation? Well, that means A and B have the same parents. All right, but of course, if A and B have the same parents, then we would also say that B and A have the same parents, and thus the ordered pair B comma A is in the relation, meaning that R is symmetric. So I have the same parents as my brother, and my brother has the same parents as me. It almost seems silly to say that because it's obvious, but that's how we're applying, that's the way that we would apply the definition of symmetric in this example. So lastly, we have to ask if this relation is transitive. All right, so we have people, let's say we have 3 people, A, B, and C. All right, and again, we're assuming that A comma B is in the relation and B comma C is in the relation. All right, so what does that mean? That means that A and B have the same parents, and also that B and C have the same parents. And again, it almost seems ridiculous at that point to say that that implies that A and C must also have the same parents. Or in other words, the ordered pair A comma C is in the relation, which proves or which shows that R is transitive. So this is kind of a cool relation because we were just able to show that it is reflexive, it is symmetric, and it is transitive. And that is exactly our definition of what it means to be an equivalence relation, which we'll get to below this video in the notes.